Okay, here we go. This time I have to remember capture. Add to existing events, boys, balls. Okay, capture. Okay, boys, so you said there was this... Okay, boys, so you said there was this smart German guy, and the way he found out all this and all that, you're about to tell me what's going on. So, what's the story, Morning Glory?
The story about how it was developed from the 70s, we have to jump to what Jacob developed.
Well, you said the 70s was very fascinating. The whole development of it, you can just...
Yeah, okay. Basically, when in the 70s, they knew they had this material, silicon nitride, which had some unique properties. And they want to make balls out of it. But the processes that they had where they could make it, they could only make sheets. So what they did was they made the sheets, they cut it out to squares, you could say. Then they cut the corners. Then you have 16 corners. You cut the 16 corners. You got what, 144, something like this. And you ended up with something which is nearly round. And then they grind it, I imagine, for weeks. Or they did it for weeks and weeks. And they ended up having something which was not in any way as nice and smooth as this one, but it was round enough to be used in a bearing. And then they start to test it.
And how long did it take to develop before they could put it in a machine?
These things could be put into a machine, but you can imagine the price for making such one. So you could say it was prototyping.
Yeah.
And the short story is that we get to the mid-90s before they have a process where they can make it from a kind of stamping. So they can make the round things and then all the grinding and the polishing, and then have something which is meant for industrial applications.
So if we go back to the 70s a little, because that's interesting in terms of the mental development here. You start with these sheets, and they experiment, and then they make these little cubes, and they cut the corners off. And from the time they started until they got something they could put in the machine, did it take a year, 2 years, I think?
I don't know it exactly, but I imagine it took maybe 5 years to 10 years. The next thing was it didn't have the properties that we know today from the material, so it was still like brittle, and especially the shock resistance. When we say ceramic, people think of pottery, and we know if you give the shock resistance, you get it a big hit, it will crack.
Yeah, right.
They did the same, and most ceramics still have this problem, even if it's not pottery.
That makes me think. I don't want to do it here. I don't want to make such a mess, but we should do it one day with the hammer and the whole deal. It's on the website, pictures of it. We should do it in a movie, I think. About these two, what happens when you take one of these made in China, right?
Yeah, and make it not only in China, but under a different process.
In a different process.
It still does not have the shock resistance that you need for heavy load industrial applications.
And as I remember, when you smash it, it turns into powder, pretty much?
Exactly. Not pretty much, it turns into powder completely.
And when you take this one, it puts a dent in the hammer?
Yeah.
Okay, that's on the website.
Because it's harder than steel. This one now is harder than steel, and it still have a high shock resistance.
Okay,